broken the circulatory system down into two parts. Today we're doing the circulatory and more of the cardiovascular functions, and then next week we're going to be doing all about the blood. So with the circulatory system, this is what you are required to know. We talk about the heart, the blood vessels, and the blood. Basically, think of a three-legged stool, three-legged chair. And these are your three legs. You need, the heart is the pump, the blood is the fluid, and the vessels is the container. We all have a pump, some fluid, and a container. All of those three things, if one of them goes down, we go down as a whole. So you've got three things, the pump, the fluid, and the container, all very affected by blood pressure, but they are all very interlinked in this system. So you need to be thinking about that. So if you, like paramedics, for example, if they're looking at blood pressure, they're going to look at all those things. Is the heart pumping at the rate it should? Is there enough fluid? What is the fluid consistency? And what's happening to the container when we look at vessels as they dilate and open, and we're going to go into that. So this is what you're expected to know. The function of the cardiovascular system, which I've listed here. You need to know the location of blood vessels, and you need to know the location, structure, and function of the following: blood vessels, heart, the cardiac cycle, electrical conduction, the types of circulation. We're going to be talking about blood pressure and the factors affecting this. I have literally pulled this information from your logbook. So, I said on the logbook, you've got the opening, it's got the introduction of each unit, what's expected, and then you've got in detail, when you look through further on, exactly what they're looking for, and this is what this screenshot is. So use this, it's your Bible, so it's telling you exactly what you need to know. Okay, so cardiovascular system, we're going to be looking at this concept. Was I telling you about London last week and presents? That must have been my sports crew. Okay, so the way I'm going to look at this, I like this image here. We're going to do just a little recap, and you can call it out. So, if I'm sure I've done this with London. No, I ain't losing the plot here. So I am biased. I am London born. I'm going to say this is the heart of the country. You're going to see it. So with London being here, imagine this is your house in Cornwall, in the country lanes, in the middle of nowhere, and this is the madness of London. So say it's just before Christmas. I need to go and collect some presents. So I'm going to do this once a year, but imagine for an erythrocyte. What's an erythrocyte? Blood cell. What kind of blood cell? Erythema is what? Red blood cell. So an erythrocyte, this is just one cycle, and it takes about a minute for one red blood cell to go from the heart, go around the body, and come back. So imagine this is 1 minute, but we're going to do it for this concept in a year. So you've got your little house in Cornwall. I'm from London. So it's just before Christmas. I need to go and pick up some presents. I'm going to go to London, go Christmas shopping, pick up what I need to. Then I'm going to go back to my little house, and I'm going to exchange literally in my bed on Christmas Day. That is the capillary bed in bed. So in order to do that, to go from your house to London, you are not going to get on the M25 right now. To get out of Cornwall is a bloody nightmare. So you're going to have to go. Imagine if you're in the depths. I'm talking Land's End in the nowhere. To get there, you are not on motorway straight away. It's logical. It's a little place. So you need to go through a little tiny arrow. These are the small vessels. You're going into the heart. You're trying to get into it. So what structure? The smallest structure going into the heart. What is that? Yes. The neurons. Now I'm going, so this is my equivalent. Imagine I'm on a country lane. And now, finally, I'm on the M25. What's the M25 equivalent? The biggest structure going back into the heart. Right? What does a pulmonary artery do?
From that.
Away from the heart to the. What does pulmonary mean? We're not talking about the lungs. I'm talking about just getting a red blood cell from my foot to my heart. So my foot is like my house. So in the depths of my body, in my pinky toe, I'm coming up to the heart and I'm trying to get back down. So I go from the foot, I go into the small passageway first, which is my country lane, say in the venules, and now I'm going into the main structure into a vein. I'm now into my heart. Just imagine now we've gone through the whole system of the pulmonary. I've got oxygen. I've picked up my presents. Brilliant. It's now Christmas Eve. I've got to get back home. My pinky toe needs some oxygen. You've got to take it back there. How are you going to get there? How do you leave London? This is a vein. Back on the M25, but I'm going away from the heart. So what is this? Artery. I go into an artery. And now I'm trying to get back into my house in the middle of nowhere. What structure? Huh? No. Arterioles. Veins go into the heart. We're talking about how we get in. And it's logical how you've got to go from a tiny little structure, then into a big structure, then into the heart. The heart's force is huge. It's just like London. You've got everyone from every part of your body. Imagine erythrocytes being like people, red blood cells like people. Everyone's going to the same destination. They're all going to the heart. It's like London. Everyone's got to go into the city. M25 is mayhem. It's mental. And so you've all got to go on. It's got to be a big enough structure, like an artery, to get everyone out. And then when you get finally further away and you start to go, well, I'm going to Cornwall, I'm going in the middle of Wales, and back in nowhere. Then you start going through smaller lanes because you've not got the speed and you've not got the amount of cells in that area. So it makes sense to have these big structures and then go into little structures. Does that make sense? Difference between venules and veins and arteries and arterioles. So you should be aware of that. And then when we get into my house, the exchange happens in the capillary bed. How thick is it? How thick are capillary beds? Wraps. Single squamous epithelium. They are one cell thick. They are very thin. To allow for what process? High concentration to low concentration. What's that called? Diffusion. Yeah. So hopefully this sums it up. So arteries will come away, carries blood away from the heart. We come through the mini ones, the mini arteries called arterioles that branch out into the capillaries. And then the venules pick it up on the other side, the smallest vein components that suck blood out of the capillaries. And then you've got the veins that carry blood back into the heart. Happy with that overall concept? Yeah? And then we'll specialise. So, let's clarify. Arteries carry blood away from the heart, and veins carry it into the heart. Just going to have a look here at the structure of these vessels. So, your tunica intima, circulatory underwear, basically. So that's the deepest layer, because we've got the term endo. Deep and within, endo. Endothelium, connective tissue, and the interstitial elastic membrane. A lumen, you should know that term anyway, because you'll see it in different structures, but mainly in vessels. A lumen just means a hole. So whenever they're talking about the hole, it's like if you've got vasoconstriction, then the lumen becomes smaller. And when you have vasodilation, when it opens, the lumen size increases. That's what that is. And tunics are just the layers. I really highly doubt that this is going to be tested on your exam. It does mention these words in your logbook, so it's good that you have an understanding of it and you're aware where they are, but I've never seen this come up in an exam. The next image I have, however. So you've got the tunica intima, tunica media, tunica externa. I'm sure if you look at these words, intima, media and externa, you'd be able to work out, well, yeah, the tunica intima is the most deep layer. The media is media for middle, and externa is externa. They're just different layers. It's quite logical, really. You know lumen means whole, tunics is the layers, and then if you look even deeper, and if there was any questions, endo, do you know that root term, that Latin term, deep and within, and then connective tissue and our elastic membrane. So you would actually, I'm sure if I tested you, now looking at the root words, be able to work that out. This is the image, however, that you're going to be tested on, which actually is pretty okay. So looking at these, they've both got an outer layer. You will be asked to label here, it'll probably be an image to drag and drop. Notice how the clues are in the image here. You've got two lines. Same label, two lines. Yes, a vein and an artery, they both have an outer layer. When you're looking at the muscular layer, they both have a muscular layer. And they both have an inner layer. So for arteries and veins, they both have an outer layer, they both have a muscle layer, and they both have an inner layer. So that's easy, because you've got three that are the same. It's only two that differs. And if you're going by the process of elimination, you know that veins have valves, because what's the function of a valve? Yeah, prevents backflow. Think of a death slide. Where are they? No, like if you're at the top of a death slide, the force going down is intense. You don't need any help going down that death slide. Gravity is going to pull you down, and the force at which you're travelling is going to pull you down. Getting to the bottom of that death slide, good luck climbing back up there. It's not going to happen. You're going to need a ladder. You're going to need rungs to help you get back up. You don't need any help going down. It's exactly the same with arteries and veins. It leaves through the aorta, boom. It doesn't need any help getting to the rest of your body. The force at which it's being pushed out is intense. But to get back from my foot to my heart, you're just walking up a ladder basically. It needs help. And so your valves do that function. And they do that all over your body, throughout all your veins, and you have valves in the heart itself as well. But arteries, you can easily tell. If I didn't have a label here, bam, you know that's an artery because it doesn't have a valve. It doesn't need any help. The force of it, just think, arteries and veins, and visualise a death slide of going down and then getting back up is much harder. So therefore, we've both got an outer layer, they've both got a muscular layer, they've both got an inner layer, but do they both have a valve? No, because only veins need it. V for vein. Vein and valves is only the veins that have them. The elastic layer, however, is in the artery. Because this is what is affected when you are stressed, for example. You're going to have norepinephrine and norepinephrine. Where they secrete from? Adrenals. They are your fight or flight hormones. When you start getting stressed and you feel like, oh my God, there's a lot going on, you are going to have those stress responses secreted into your bloodstream. You're going to have those hormones secreted. And what they do is they are going to dilate your blood vessels or constrict. That when you're stressed and when you're not stressed, you have these changes that happen. And the elastic layer plays a big part of that. It allows things to dilate and open. So if we need to start running, we're going to have blood vessels dilate because I need more blood going to my muscles to help me run. Or if I'm nice and calm and chilled, there may be constriction going on. We said in our sympathetic nervous system with fight or flight, we need muscles to really work hard. But in the parasympathetic, when we've got the restriction of the throat, the pupils constrict, we're nice and calm, our elastic layer is going to be much tighter. It's going to work and open when we need more blood. So the arteries play a big part of that. The veins are just trying to get the blood back up to the heart. They don't have a big part in that opening or closing. So that's the difference between the valve, V for vein, and the muscular layer is in the artery. So you will be asked to label that image. I have got some images here for you guys, and the labels are on there, but I would recommend colouring the layers differently, or I've just printed in black and white, so you could use, if you want a highlighter, or you could cut them out, make a little flashcard with it. You can cut them out and make your own labels. I'll take one of them. Yeah, she should be in tomorrow. Oh, so yeah. So I'd recommend kind of looking at this for your homework and using some colour to help you differentiate between the layers, because it's important that you know that. Any questions on arteries and veins? What ones have valves? Vein. Hallelujah. Got there. Yeah. This image, however, is a little bit trickier. And if you look at the terms in your logbook that I showed you, the screenshot that I printed, it had in there all the terms you're expected to know for the location of arteries and veins. These are the terms I've highlighted here that maybe we're not so comfortable with. We're going to break this down. So I'm going to go through with this, how you should be able to understand the wording. So jugular, where is that? We all know in the neck. If that is sliced, it's game over, I'm afraid. So your jugular veins, you should know that word, it's in the neck. Sometimes you can think of this, if you think of like one of those old school jug images that you see. Like a permanent marker. Like it's this neck area. If you think of a jug, that's how one of my students like to think of it. And I think, if you ever get stuck with that image, it is in the neck, so maybe that would help you. Carotid, where does this artery go to? Heart. No, because it's an artery. So where is it going? Away from the heart. Away from the heart to the head. Carotid is going to your head. So if anyone is having a stroke, for example, then there is a blockage in the carotid artery. So if you had an aneurysm or a burst, aneurysm is where you have this burst in an artery or an aneurysm in the carotid artery, there's going to be no blood going into the head. And you've only got a limited time frame there. So the carotid artery goes to the head. Pulmonary arteries, where are they going to? What's an artery? It's going away from the heart. It can never go to the heart if it's an artery. Away from the heart. So pulmonary means what? Arteries mean from, yeah. Where does pulmonary vein go, Maxine?
Pulmonary vein must go, hang on, let me think, to the heart.
Yes. From the lungs, yeah. The heart, we've got thoracic aorta. What's the aorta? The main what?
Comes from the heart. Artery.
Artery. A for artery. It's the main artery in the body. It's in the thoracic region, we know that. We've got the parts of the neck. What's the neck called? Cervical. Then we've got lumbar. Then you've got sacrum, and then you've got coccyx. You need to retain this information for your clients. Maybe not for an exam now, but you need to keep refreshing that. Yeah, so we know it's in that thoracic area. Hepatic. Any idea what hepatic means? Your hepatic artery, is it going away from the heart or to the heart? Away.
It's an artery.
Hepatic is liver.
Oh yes.
So your hepatic artery is going away from the heart to the liver. So you need to know that term. What does carotid mean? Head. Jugular is in the neck. So hepatic is liver. Superior, mesenteric. Any idea what the mesenteric area is?
Feet. Fingers.
No.
Where is it?
The clue is in the title there. It's in the
Oh,
image.
no.
Digestive system.
Oh, okay.
It's in the digestive system. So hepatic means what?
Liver.
Yeah. Carotid is what?
Yeah.
And then you've got mesenteric is digestive. Renals, you know this. Kidneys. Because what's the stress hormone that's secreted from the adrenals? epinephrine. Epinephrine affects the heart, and norepinephrine will affect the vessels. So they're doing the same thing. They're working with your stress response. They just do slightly different jobs. So that's your renal artery, abdominal aorta. You would hopefully know that area. Common iliac. What's the iliac? It's your hips. Your ilium is the top of the hips. Your pubis is the front, and your ischium is the base. The ilium, we always talk about the iliac crest, the anterior, superior iliac spine, your ASIS, PSIS, is all about the ilium is your hips. So the iliac artery, iliac vein. So now you need to be looking at the colours. Iliac vein, renal vein. Renal means what?
Kidney.
Kidney. Gastric vein. Yeah. We've got basilic and brachial. Brachial is what? Arm, yeah, because you've got the bicep, brachii. Whereas we've got, what's the name of the biggest hamstring? Bicep. Femoris. So that's the bicep of the leg. And this is the biceps brachii, as in biceps of the arm. The brachial area is the arm. The vena caves we've already discussed. What's the aorta? What kind of artery? The biggest artery in the body, yes. So I have got some images that I am going to hand round for you guys. So, because I want you to label, but I just want you to have a look at this image, because with your VTCT exam, they are going to ask you to label, and can you see right at the bottom, it says arterial and venous.
Oh.
And they're going to have labels for you there, and they're quite tricky. It's a tricky question, but if you don't read the question and take your time and look at the labels, you could be labelling the thoracic aorta on the venous structure. So that's why I really want you to highlight that, and I'm going to get your printouts.
It's not, I'm like, yeah.
I'll call you back and then
Friday off and prepare for 2 exams. Honestly. If it's any worse than what it was the first time, then I need another exam.
I think I'll come in on Friday and have all the answers from my Thursday lot.
I want to do the exam on Friday, yeah.
That's the way to do it. It's so stressful, isn't it, with the slowness of it.
Oh
man, I don't want to live through that again. I wish I could. My bloody, what, me, I can't remember what it's called. Main artery. Can't cope with it.
The printer's been really good to you guys. So instead, I want you to think about what is the difference between pulmonary circulation and systemic circulation. And I'd also like you to write up your explanation of cellular respiration. I'll give you 2 minutes.
was the other
two
question.
questions.
That was the other question.
Oh, well, should we do that one?
Just to have a say a one-line sentence.
So what was the I'll ask that and then I'll do the sewing one.
So explain pulmonary circulation. What was the other one?
Systemic circulation, but it's the difference between them.
Oh, systemic.
Systemic circulation.
All got a explanation of how you describe cellular respiration? Tash, what's yours? Breathing. Is this to the point? Anyone else got any others? What's yours?
I
Tim?
wrote what you said earlier. The act of breathing, supplying the cells with water.
Yeah, supplying the cells with oxygen, keeping them alive.
Also, your functions depend on energy generated and transportation to substances within and between the cells. Cell respiration refers to the cell use of nutrients such as oxygen and glucose to activate the energy.
Yeah, that is what cellular respiration is. But if I ask you next week, are you going to be able to say that? That's why I keep saying in your own words. There's no point just copying something from a book because you won't learn it. You're not going to retain it. You've got to read that information, process it, turn it into your own words, tell someone else, and actually understand it. So I want a sentence that I ask you, you understand it, and you're like, yeah, I know what that means. If like Tash is breathing, we all know what breathing is. Like, it's short, but yes, it is breathing. A little bit more information about like a sentence, but we're going from one extreme of one word to 100 words. We've got to find a midway point. So, but please try and get it so you could verbally explain it to someone if they ask you and know what it is. Okay, so I've just given you your handout sheets so you can see. Please have a go labelling. How did you all get on, by the way, with that homework I gave you, the handout sheets of pulmonary circulation?
I didn't understand it.
You didn't understand it?
Did you use the words at the bottom?
Yep.
Okay. I did like a process, like of elimination, the ones that I knew, and then the other ones sort of fitted in.
That was after we just done the respiratory system, so I'm sure after today, have another go. So I did say it's kind of a two-parter, really. Respiratory and circulatory are very, and cardiovascular, they're very overlapping with regards to that. So today, hopefully it'll make more sense. Had a go? Do you want a few more minutes? Yeah. How many more labels have you got left?
Loads.
Loads? Yeah, I'll give you a few more minutes. we go through it? Yeah, are you still going? We need more time. We just go through it together. Let's start in the top left-hand corner, the top right-hand corner of your sheet. What did you get? Jugular. Yeah, because it's in the neck. Jugular vein. Yeah. Next one down, Serena. It's going to the head. Yeah. Carotid artery. Yeah. Maxine, next one down.
I didn't do it, but I think it's the. Hang on 2 seconds. I don't know.
Yeah. What did you get, Judith?
The pulmonary arteries.
Yes. Charlie, what did you get for the next one down?
The pulmonary vein.
Yes, correct. And then Maxine, what did you get for the next one down?
Heart.
Yeah. And then Ada, what's under the heart?
I didn't get that.
It's in the mid-back area. What did you get, Kim?
Is it hepatic artery?
No, I just said it's in the mid-back
Oh.
area, like thoracic aorta.
Oh.
Yeah. If you look up, the location, what does hepatic mean?
Liver.
Yeah, so because of that location, it can't be that high up. Next one down, however, would be the hepatic artery. And then next one, Tash?
Is it the
Yes.
superior
Mesenteric artery, yeah. What does mesenteric mean?
Digestive.
Yeah, it's going to the digestive system. You have these mesentery folds in the digestive system. Then next one down, Serena. Renal artery. What does renal mean? Kidneys. Yeah. Next one down, Maxine.
I didn't do it.
As a guess. What? Did anyone else get it?
abdominal.
Abdominal aorta. And then you're going down into the hips. Did you get that one, Maxine? So
Iliac.
yes. Common iliac artery.
Oh, see, I've got them all the wrong way round. I've done veins instead of arteries, it seems.
Yeah, you've just got to look at the colour. I know
Yeah.
yours is black and white, isn't it?
Yeah.
But
I couldn't remember which way round it was. Which one was
yeah,
which?
generally the red is darker,
I thought. Oh, yeah.
and it would be like it's brighter in life. It's still red blood that is running through your veins. It's just it's not as bright because it's the oxygen within the hemoglobin that gives it the brightness, and so it's just darker and duller if it's a vein, but it's brighter and more vibrant if it's red. So the next one we've got the iliac vein coming up. Charlie, what's above the iliac vein? Renal vein. What does renal mean?
Kidney.
Yeah. Next one up, Judith.
The gastric vein.
Gastric vein, correct. Then we've got next one up. Yeah. So that the basilic. Yeah. The basilic is just that. It's specific that term to the inner arm, like that arm, the vein in the inner arm, the basilic vein. It's very superficial on the inside of the arm. Above that, what have we got? What did you get, Kim?
The brachial artery.
Brachial artery. What does brachial mean?
Arm.
Yeah. And then we've got next one, Ada.
I just didn't follow those to begin.
Imagine it's coming from the foot.
Yes.
So I've got a red blood cell coming from the foot,
Yeah.
and it's entering back into the heart. So it's a vein or an artery.
Vein.
Yeah. And you're either coming from below or above. I'm coming from the foot. So that's below the heart.
Below, yeah. So it's not superior. Is which one? Inferior vena cava.
Yes, correct. Inferior vena cava, and the higher one is the superior vena cava, and then we've got the biggest artery in the body, which is the aorta. Yeah, good work. So that's the answers back there. We're going to do this again tomorrow. I think this is probably the trickiest part of this whole system. I think labelling this, if you can get your head around this, you're doing really well, because they're all pretty new terms, and they all look very similar, and it's kind of just getting to know the location of these labels. So I appreciate that it is a really tough image to label, and it's just going to take practice. So we'll have time. So it will be this one, and then the labelling of the heart are your two images that I really want you to focus on. But again, we'll have a go tomorrow. I'd learn these terms here. You should know these. Hepatic meaning then digestive, and these terms are obviously like the carotid. We know. I've just put a few extra ones in there, but you should know that iliac meaning hip. So yeah. Like I said, when you get an image in your exam, really be careful and read it. Take your time and look at the labels. It'll either be above or below, and I'll put them below here, the arterial or the venous, and it'll get you to label it from there. What's the difference between pulmonary circulation and systemic? Pulmonary is going to the lungs, heart to the lungs, lungs to the heart. It's what we did last week. Pulmonary circulation, and that's really involved with the respiratory system. We're looking at systemic circulation. It's your system, it's your whole system circulation. It's going around the whole body. So the pulmonary is just going heart to lungs, lungs to heart, and your systemic is going heart to body, body to heart. So they're these two systems, this interplays. So we've got the pulmonary circulation loop and the systemic loop. This is what we're going to go over in detail. So we're going to start. This is more of a physiology map. So an anatomist's map would be with that exact anatomy, whereas this is more functional, how it works. So starting chamber 1, we go from the right artery, right atrium, we come through the tricuspid valve. It's basically a peace-looking valve. So you've got two valves. You've got one on the right between the atrium and the ventricle, and one on the left between the left atrium and the left ventricle. The one on the right has 3 parts to it, and the one on the left has 2. So it's got 3 parts. It looks like this peace sign. So this is the tricuspid. And the other one on the left-hand side is called the bicuspid. So the tricuspid is on the right side, and the bicuspid is on the left side. This is what anatomists use, because when they literally cut through that vein, that valve. What's the function of a valve? Stop that flow. That when they literally cut it open, they can see this division. There's like 3 parts of it. That's why it's called a tricuspid. And when they slit open the left valve between the left atrium and ventricle, they see 2. They literally see it. There's 2 parts. So they call it the tricuspid and the bicuspid. Life is easy, right? 3 folds, 2 folds. But physiologists have come in and started calling the bicuspid the mitral, just to throw everyone off for no logical reason. So apologies, but you have to learn mitral. Tricuspid is on the right. And just think of this as well, like the lobes of the lungs. How many lobes does the right lung have? 3. Why does the left lung have less?
Cut out for a heart.
Yes, exactly. So it's the same with the valves. On the right side, you've got 3 parts to the valve, and on the left, you've got 2. So if you get confused, think of that. So we've got right atrium. We come through what valve? Tricuspid. You say it, Kim.
Tricuspid.
Ada?
Tricuspid.
Try.
I can't say it.
Cuspid. Say cuspid.
Cuspid.
Try.
Tricuspid.
Oh, it is the tricuspid.
Correct. We then come into the right
That's the
ventricle.
way to remember.
We now come up through the pulmonary artery because I need to go away from the heart to pick up some oxygen. So I travel. I come through the pulmonary artery. Right, now I'm in the capillary bed. How thick is a capillary bed?
1 layer.
Yes, made of what tissue?
Simple squamous.
Simple squamous epithelium. Correct. Now we come in through the pulmonary vein. I come back into the left atrium. And I now go through the mitral valve. Please repeat, Tash.
Mitral valve.
Yes, into the left ventricle. This is the strongest ventricle. It pushes. I now go out through the biggest artery in the body, out through the aorta, and I can either choose, or I go to the upper body, through the carotid artery into the head, or maybe I'll go through to the hepatic portal, I'll go to the mesenteric, maybe I'll go to the iliac artery, and then I'm going to come back up through the inferior vena cava. Start all over again. That's your system.
I never could do that.
The portal vein, you only have this in a few parts of your body, but where you can see it, because the liver requires so much blood, that the liver has got its own artery, known as the hepatic artery, but also you've got the digestive system, the mesenteric artery, which goes through that, and then it goes back through the liver. So it's this portal system. It's going from a organ to an organ, and that rarely happens in the body. So if you ever see a portal vein, it's not going to be anywhere in the lower body, it's not going to be anywhere higher up, it's only going to be from the digestive system to the liver. So the portal vein, you can quite obviously see there that it's not coming, it's obviously quite obviously it's portal, because it's going from one to the other, and it's not going from the heart to an organ, or from an organ to the heart. It's literally in that little chunk. So you are going to be labelling this, guys, but we're going to have a break. Let's go for a coffee, and then come back, and then we're going to go through this in detail. So a real lot of information to take on board in this one, and that's why I've split it into two. Can you imagine if we now had to go through all the blood as well? Too much. I'm impressed though, you're staying with me.
I get frustrated. I just want to remember it. I want you to say it once and I'll remember it. And I can't.